Hello everyone. In this video, we are going to discuss change of independent variable. So discuss here one formula. So there is a function of x and y. X and y are functions of u and v. Then there is these two partial derivatives formula. So how to remember this formula? So we'll discuss or we'll try to understand this formula by using a tree diagram. So same, it is z function of x and y variable, and x is a function of u and v variable, and y is a function of u and v variable. So see first, that is we use the partial derivative because there is a function of two variables, not a single variable. So that's why we are using here partial derivative concept. So z with respect to x, we write here dou z by dou x is dou z by dou x. We want to find the z with respect to u here. So there is two components, one z with respect to x and here x with respect to a. Z with respect to x and x with respect to u. From this, z with respect to y, z with respect to y is plus, then y with respect to u. So y with respect to u. For second formula, z with respect to v now. Z with respect to v, z with respect to v equal to z with respect to x into x with respect to v is plus, now dou z with respect to y, z with respect to y, then y with respect to v, y with respect to v. So you can remember this formula. Now discuss this example. So z is a function of u and v, and u is a function of x, and u and v is a function of x and y. So show that this is. So see, given here, z is a function of u and v, and u is a function of x and y, but given here this relation, so y equal to Ly minus mx. Now first find the derivative of the z with respect to x, because it is with respect to x, so with respect to x here. Okay, where is the formula? From the formula. The first is z with respect to u into then u with respect to x plus, okay, now z with respect to v, z with respect to v, then v, there is v with respect to x, this v with respect to x. So now find here partial derivatives. So u with respect to x, so derivative of is Lx, this here derivative of u with respect to x here. So derivative of x with respect to x here, 1 is here L, then plus here is no x, so derivative of is 0, so it is L. So dou u by dou x here L, so put here L. So L into dou z by dou u. Okay, now plus v with respect to x, this is v. So v with respect to x here. So here is no x, this is constant, derivative is 0 minus derivative of x is 1 into minus x. So here right here minus m. So we can write here it's minus m z with respect to here. Okay, now we can form here operator dou x. Dou x is dou u minus m dou by dou v. Okay, we use this operator to form the second derivative. So this is equation number 1. Now partially differentiate equation 1 with respect to x. So here second order partial derivatives dou 2z by dou x square. We write this as we are differentiating this function dou z by dou x with respect to x. So here for first order partial derivatives. Again differentiate, we get here second order partial derivatives. So we can write this as dou by dou x and here dou z by dou x. So dou by dou x is dou by dou x here this operator. So write this operator there is R L. Okay, dou by dou u minus m then dou by dou v. And we know that dou z by dou x is from this one. Dou z by dou x here this I dou z by dou u minus m dou z by dou I L dou by dou u minus m dou by dou v. Okay, now multiply this. So first this component multiply to these two components, which are L into L square and partial derivatives differential dou. So here is z. So dou by dou u into dou z by dou u, which we write here second order of z with respect to u. Reduce. Now this component to this, so L into minus here minus L m and here partial derivative of this here dou z by dou v and here dou by dou u. This here dou z by dou u into dou v. Now multiply this component to these two. So now minus m into L is here minus Lm. Okay, then here dou is here dou 2 z by dou v into dou u. We write here dou v. Now last here this minus plus m into m square and dou by dou v and dou z by dou v. We write here second order partial derivatives dou 2z by dou v square. So we can write this as equal to L square dou 2 z by dou u square minus add this we get here minus 2 Lm dou 2z by dou u into dou v plus m square dou 2z by dou v square. So this is equation number 2. So similarly for dou z with respect to v, we are here differentiating with respect to x. Now here differentiating with respect to y. So for differentiating, so formula is here dou z with respect to u into u with respect to y. Okay, then z with respect to v and v with respect to y. Now find here u with respect to y, v with respect to y. So see this relation u with respect to y. So derivative of u with respect to y is here m and this derivative is 0. So m, we get is m. So m into dou z by dou u. Okay, then v with respect to y. So v with respect to y is here. So L, so plus L, so plus L into dou z by dou. Okay, now same way we can compute this second order partial derivatives in the same way. As you can see, we write the operator as dou by dou y equal to m dou by dou u plus L dou by dou v. So this is equation number third. So this is operator, second operator with respect to y here. So now second order partial derivative, right here dou to z by dou y square with respect to y. So you can write it as dou by dou y and dou z by dou y. So dou by dou y here is operator m dou by dou plus L dou by dou v and dou z by dou y is here m dou z plus L. Now multiply this two bracket this component m into m square partial derivatives dou by dou u dou z by dou u is dou to z by dou u square plus m into n is ml dou by dou u dou z by dou u you can write a second derivative dou z with respect to here dou u into dou v then plus L into m. So m L same dou to z by dou v dou u. You can write here this as a dou u dou v then plus last L into L square and it here dou to z by dou v. Okay, so this is equation number 4. Now equation 2. This equation 2 and equation 4 add. So equation 2 plus equation 4. What we get? So here dou to z by dou x square plus dou to z by dou y square equal to, now add this add. So we write this statement as suppose that delete this, erase, first simplify this here. So add these two, so we get here m square dou to z by dou u square plus twice ml dou to z by dou u into dou v plus L square dou to z by dou v square. So this is equation number 4. So equation 2 and equation number 4, by adding these two equations we get here dou to z by dou x square plus dou to z by dou y square. So add this, it is m square dou to z by dou y square and m square dou to z by dou u square is here twice. Yes, add these two. So here is L square dou to z by dou u square and m square dou to z by dou u square. From these two terms, so take the common here dou to z by dou u square dou to z by dou u square. So we get here L square plus m square. So L square plus m square. Here is dou to z by dou u square. Now second term, it is positive ml, not here is minus 2l m dou to z by dou u into dou v, this plus, so both here cancelled. Next here m square dou 2z by dou v square, and is here L square dou 2z by dou v square. So take common here dou 2z by dou v square. You get here L square plus m square dou 2z by dou v square. Now take common here L square plus m square. And in second bracket dou 2z by dou v square dou 2z by dou v square. So hence proof. बता दिए हम लोग कि this side equal to this side. Thank you.